Hi, we are from Group Gen 2, and today we're going to demonstrate our mini project. So first and foremost, I'm going to show our general part, means our group part, which is network configuration. So my name is Chazi. I will now show you the adapter, the network setting. So now we look for server, we go to machine setting and network. So you can see here for adapter 1, we attach to NAT for external access. And for adapter 2, we attach to internal network, name it as Baksulan. And then now we check for client. The same step, and then we're going for network adapter 1, we're setting it to internal network and name it the same Baksulan, same as the server 1. So this one, to make it connect strictly via this name for secure infrastructure isolation. Right. Now we're going to server machine and I will show you the host name. So here is our host name, OS class. Next, I'm going to show our network interface. All right, so you can see here, this is our, for ENP0S3 is set to dynamic DHCP. And then for ENP0S8 is bound to our manual static gateway IP of 192.168.1 and 454. All right, now we get out, we can press Ctrl X. Okay, so now I'll show you the IP address. We run the command IPA. Then you can see here, this is the IP address that we set. Okay, now this is on server. We're going to client, we run the same thing, IPA. See here, this is the address pool we set. Next, we're going to test our connectivity, which show client talk to server. So we stay on the client terminal and then we ping the server gateway. That ping negative minus C, okay. Ping minus C, 3, ping the address 192.168.1.25. So to prove the client can talk directly to the server over our local virtual switch, as shown, the connection passed through smoothly with 0% packet loss. Okay. So now we switch to terminal, server terminal. We ping the public resolver, which is ping minus C, 3, then 3, 8.8.8.8. This is our public resolver, and press enter. On the server, ping 8.8.8 is completely successful because of our upstream NAT interface setup. You can see here, 0% packet loss. All right, switch back to our client terminal. As you can see, we can ping the same command. We press enter. Just wait for a while. Okay. So you can see, we ping on the client terminal completely failed with 100% packet loss. This proves our initial network parameter policy successfully keep the client securely isolated. So that's all for our group part, which is network configuring. Now I will continue to my DHCP part. So first, continue to our DHCP part. Okay, first, before we enter the testing command, I will now explain the usage of DHCP. DHCP is a network service that automatically assigns an IP address for client device. So we will start the command in server terminal. So we're going to test our status first to see the status to show where to show whether the DHCP is active running or not. So we type the command sudo systemctl status isc-dhcp-server. Press enter. You can see here the command proof the service daemon is active running in green text. And then this proves that our DHCP is actively now. So you can see this is all the Dora things. You know what is Dora? Dora is a 4-hand straight stack, which D is stand for discover, O is offer, R is request, and A is acknowledge. And then we can press Ctrl C to get out. Now we're going to do the verification. Stay on the server terminal, and then we will execute a live connection check using ping -v3 google.com, and then we enter. So to verify that the server background connectivity remains perfectly stable while handling the active DHCP daemon, we execute the ping to check out the Google, and then you can see here 0% packets lost, means that the link is respond cleanly with 0 lag. Alright, so we switch over to the client terminal, and then we run IPA. This client interface has dynamically list the target IP address of 192.168.168.1/24, which come out straight out of our configure server pool scope. Then we continue to another command. So by running this command, we can notice that the client still cannot reach the public internet because boundary transit forwarding is turned off. This is the proof of getting 100% packet loss. We switch to the server terminal, and then we type some setting to let client can access the internet. Enter. So I show IP forward equal to 1. Then another one is IP table. So now we already enable the routing. We turn on the kernel IPv4 forwarding and add a masquerade rule to the server IP tables net layer. We return to the client terminal, and then we ping one more time. So with the exact same ping to Google, is now 100% successful with 0 packet loss. This confirms that our base network dynamic DHCP leasing and custom perimeter net routing are completely operational. Thank you. That's all for DHCP part, and I will pass to SFTP.
Okay, my name is Muhammad Taufik, and today I'm going to present about SFTP. Okay, first of all, on my right side is the server, and the left side is the client. Okay, first we go to the server, then we type /etc /ssh/sshd underscore etc. Oh, wait, nano. And we go to the nano. Okay, after we enter the nano, we scroll down to the bottom, and then we find the mesh group Baso SFTP. Okay, we added a mesh group block at Baso SFTP. This just user in this group to the home W directory root and forces them to use FFTP only, preventing them from accessing a full common shell. Okay, for the validation SSDT, before I change, I run a syntax check. If returns nothing, our calculation is valid. Um, okay, I run validation SHDT. Okay, if it returns nothing, the syntax configuration is valid. And then I will restart the system. I am now restarting the service to make our security rules active. System CTL restart. SSH SSH
Hello. My name is Hong Wei Yu. My metric numbers is B1525164. Today I will be demonstrating the configuration for the web service. First, I will explain the usage of the web service in our project. We developed the FS2 server service to act as our company's application presentation layer. Its primary usage is to securely host the BASU 1213 corporate portal because this service is bound exclusively to our internal gateway IP 192.168.1.254. It ensures that our web content is strictly isolated from the public internet. Okay. Okay. To verify the server is running, I am checking the system's status. As you can see, the FS2 HTTP server is loaded, active, and running perfectly. Okay, next, I will show how I fulfill the requirement to design a sample web page by displaying the index HTML file. You can see I did not use the default Apache landing page. I wrote custom HTML and CSS to create a secure enterprise container specifically adding the header. Welcome to BASU 1213 Corporate Gateway and online status indicator. Okay, now I am switching to the Visual Linux client to explain how testing is being done. To testing methodology requires us to verify that a client machine, which is completely isolated from the outside internet, can successfully request web content from the server's internal gateway. Okay, by running the IPA command, we confirm that this client has dynamically received a internal IP address from our DHCP server, placing it securely inside the BASU LAN subnet. Before opening the browser, I will ping the server gateway IP. I 192.168.1.154. The successful replies prove that our internal routing is working. Now let us test the actual web page. Okay, finally, I will show the web page from the client. I type the gateway IP into the browser. As you can see, the custom BASU 1213 Corporate Gateway renders instantly and perfectly. This proves the web service is functioning correctly in our isolated network. That concludes my demonstration. Thank you.
Okay, good morning. Good morning, sir. My name is Magat. B152510107. Okay, so today I'll be presenting demonstration for Debian database. All right, here's my face. Okay, so for database, we don't need to use client window. We can just use the server window. So all we need to do right now, I've already created. We should create a database. So I'll create a database example. So for example, create database bakery or classroom. Classroom is easier. Classroom. And there you go. As you can see, one database has been created. Now, to use it, we have to use this command, use classroom. And then you have to add those semicolon. And now the database has changed. Once the database has changed, we have to make the table in the database. So, for example, create table for in a classroom the students. So, yes, create table students bracket, and now we add their ID, the student metric number, maybe that's entirely unique, their names, water chop, 20, hopefully the name's not that long, and then GPA decimal, yeah, the GPA, anyone who's like 1.5 or 4 flat, whatever, and then you close with a bracket, and there, the table has been made. Query okay. Now once that is done, once the table is made, we should we should be able to insert the value of students. We should be able to insert the names of students. So for example, insert into students, the student table, students table, values. We need to put a bracket. So let's say this person's metric number is 12. Okay, this integer 12, Abu. And his GPA is 3.9. Yes, 3.9. We can also add another person. For example, 1 Bob 2.0. Yes. These are the values that we're going to enter into the table. Unknown column Abu in values. Unless that's not the right name. Hold on. You should try it as a name. Such a strange predicament. We cannot add. Oh, my bad. You're supposed to put in, okay. Now we've put in the values into the table. For example, insert into students values. The names, they have to be in quotes. So for example, they have to be in quotes. So Abu, that's wrong. Abu 3.90. There, one row has been inserted in. We can also add more students into, for example, insert into students values. Let's say his metric number is 9. Ali 4. He's smart. Let's say. And then there's another row. So these are 2 students into the database. And now, if we're using a database, we want to see if we can call that information. So we want to select from the students table. Let's say you want to select, we just want to see the table, and there you go. We actually do see the table. ID, the name, the GPA of the 2 students, Abu Ali and the GPA. And you can make it larger, longer, and wider if you want. You can also update the data that's already in the table. So for example, update students. We want to change that. Let's say we want to change the GPA. They didn't do that good this semester. Set GPA 3.00. Where we have to, this where is where we select the students. So where ID is let's say Abu. ID is 1. Abu's ID is 1. So we use Abu, and there it has query OK. So if you want to see it, select from students. And there you go. You see, Abu has dropped. Poor guy, he has dropped. We can also delete data in the database, all on the server only. So for example, delete from students where ID, let's say ID got expelled. Let's say where ID equals 9. And you can see it again in the table. Select students from students, sorry. From students, that's wrong. That's wrong. Hold up. Select from students. There, ID's gone. And you can also continue to add things. But yeah, this is the demonstration of database on Debian. And that's it. Thank you.
This is our Q&A session for our project. So we'll start the first question now.
Okay, for the I have a question for you about the HCP.
Yes.
The first question is, what is the usage of the HCP?
So DHCP is a network service that automatically assigns IP address to client device. It is good also to prevent the IP address conflict. So, next question.
Another question is, what is DORA process?
So DORA is a four-step handshake, like four-step handshake that the client server and the DHCP server use to automatically negotiate an IP address to this. So D is actually stand for discover, O is stand for offer, R is stand for request, and A is stand for acknowledge. Right now I have a question about database. So question 1, how do you install the default MariaDB database server on the system?
So to install the default database, which is MariaDB, there are 2 steps. The first step, you have to download or update the local package index, and the second step, you have to input a command, which is sudo apt install MariaDB server, and that's how you install the database.
Alright, I have another question. So how do you verify that the database service is up and running after the installation?
To verify it, you can just check it in the terminal. The terminal has, you can input a line of code to see whether queries are accepted or not, and that's pretty much it for MariaDB. But now I have a question for Wei-Yu. Hold on, I have a question for Wei-Yu. Why do we use the exact IP address to access the portal?
Because we haven't configured a DNS server like Byte9 in our network, so we could bypass this by editing the client's etc per host files, but using the asset IP directly is the fastest and most solid proof that our internal routing is working.
But now, another thing I don't understand. Since our Linux server has internet access, what stops people from the outside from accessing our website?
2 reasons. First is VisualBox automatically drops outside requests unless we especially configure port forwarding. Second, for maximum security, we can edit npx box.conf to strictly listen the get IP address, forcing it to completely ignore outside traffic. That's all. Then I have some question about the FSTP. The first question is, in a Unix-like operation system, which signal is typically sent to a process to pace or stop its execution without terminating it, and how does it different from a kill signal?
Okay, if you want to pause, if you want to stop, and if you want to kill the signal, for the stop signal, you just have to write sign stop, and it will make the system just suspend the execution, but it is still running in the background. And for the kill signal, you just have to type sign kill, and then the system will terminate itself. So if you want to use it again, you just restart it.
Next, if you are using a command line interface and a process is running in the foreground, what keyboard shortcut is commonly used to send an interrupt signal to stop or terminate that specific process?
Usually we use Ctrl+C to terminate all process.
Okay, thank you.
Thank you. So
Okay,
that's
thank
all
you.
for our Q&A session. Thank you.